Hello, everyone. Welcome to our demo number 4. We're the team Rapdev, and first of all, I'm going to do a small recap of what we did in the previous demos. So in the previous demos, we successfully pushed the trace data from the demo application to the Datadog APM. In addition, we also deployed the Jenkins to our remote server, and we built the skeleton for the continuous integration, the CI part. And furthermore, we tested the CI using a GitHub repo to trigger it. And our goal for the final project is to build a CI/CD pipeline that supports different microservices. And in addition to that, we want to build a microservice performance monitoring system. For example, getting the metrics as well as monitors the setup and create the dashboard, and as well as using APM. And furthermore, our goal is to allow the developers to be able to spin up the APM and the CI/CD pipeline quickly with a minimum number of code changes, which means we want to build the system to dynamically adapt to fast-paced developing environments. And what we have accomplished for the sprint number 4 is we resolved the issue in getting the trace data to the Datadog using ddtrace. We also learned a lot about the Terraform, and we set up the infrastructure we need in order to use the Terraform. And in addition to that, we also created the Datadog dashboard using the Terraform, and we connected the Jenkins pipeline to our Kubernetes cluster, and we complete all the stages of Jenkins pipeline for multiple microservices. And we also have different containers now for each of the microservices that we pulled from the Docker Hub and deploy them on the Kubernetes. And furthermore, we configured and deployed our Kubernetes clusters on our AWS EC2 instance. So now I'm going to hand over to my teammates.
So this is the overview of CI/CD architecture. So the last sprint, we completed these steps where we built the Docker image, pushed latest Docker image to Docker Hub, and then pulled the latest Docker image from Docker Hub. So in this sprint, we have integrated the Kubernetes with our application. We deployed the Docker image from a previous step to the Kubernetes cluster. So in this, as you can see, we have 2 Jenkins instances, one master and one slave. We also have a AWS EKS instance and 2 Python microservices cluster nodes created by using the ekctl command.
We have used Amazon EKS cluster because it's beginner friendly. The ekctl command basically uses cloud formation under the hood to create one stack for the EKS master control panel and another stack for the worker nodes. Let's just quickly go through the demo for the entire CI/CD pipeline. So this is a GitHub repo where our microservices files are. I'm just going to make a slight change to Jenkins file. I have made the changes and committed. The Jenkins pipeline is configured to automatically start a build as soon as the commit has been made. As you can see, the new pipeline has started, and these are the final stages. Currently, we are facing some issues with our EKS nodes, and that will be resolved in the next sprint. In this stage, the images have been built, and here it goes to the Docker Hub, where each microservice has a repository. Then the latest image from each of these repositories are then deployed to the clusters. As we can see, the pipeline has been completed and the application has been deployed.
We're giving a short demo about two things. The first being deploying the infrastructure, and this is what the infrastructure will look like, which will be deployed using Terraform. And the second is creation of dashboard on Datadog using Terraform. For deploying the infrastructure, we have two files. The first being the providers file, where we define the required providers. In our case, it is AWS. And the second file is the main file, where we define all the resources that we'll be needing, such as the AWS VPC, the subnets, the internet gateway, the routing tables, the association specific to the routing tables, the EKS configuration, the IAM role, as well as the policies relevant for the roles. Now here we will be using the Terraform init command. So the Terraform init command will help you to will be used to initialize the required plugins. And once we initialize the plugins, we can use the Terraform plan command. The Terraform plan command creates an execution plan. By default, a plan consists of firstly reading the current state of any existing remote objects to make sure that the Terraform state is up to date. It will also propose a set of change actions that it should apply and make the remote objects match the current configuration. And to apply this configuration, we use the Terraform apply command. So all the configurations will now be applied. This will take some time. So now the Terraform apply command is completed. Let's check if the resources are created here. So in the VPC, so the VPC is created. We also created 4 subnets, that is 2 private and 2 public. So those are also created. And also we created EKS cluster. So yeah, even that is created. We will now destroy the configuration using the Terraform destroy command. This will take some time. In this part of the demo, we will be creating dashboard in Datadog using Terraform. Let's take a look at the configuration file. The main.tf file here contains the provider. In our case, it is the Datadog, and we define the resources, which is the Datadog dashboard. And in the Datadog dashboard, we define the widgets. So widgets can be considered as the charts that will be displayed on the dashboard. So we have written the configuration for 4 charts. The first will provide the number of running containers. The second will provide the running containers by image. The third one will provide the CPU used by Docker image. And the fourth one will provide the service map. So before applying the changes, let's see if the Terraform dashboard is already present. As you see, there is no Terraform dashboard which is already created. So let's apply this Terraform using Terraform apply command. So the dashboard should be created now. Let me search it. So the dashboard is created here. As you can see, the 4 charts that we had configured are visible on this particular dashboard. And we can destroy this configuration by using the Terraform destroy command.
We are facing some challenges in deploying the images saved in Docker Hub on Kubernetes. This is the burn down chart for the sprint. We were able to complete 32 points out of the total 48 points. The tasks pending are to deploy the images on Kubernetes and to test the complete CI/CD pipeline. These are the tasks for the next sprint. to deploy the application on the configured Kubernetes cluster locally and on the AWS cluster, to add additional charts, the Datadog dashboard for infrastructure and CI/CD monitoring, to research on and work on the synthetic tests, and the last one would be to use Terraform to automate the Jenkins pipeline and dashboard creation. Thank you.